Hi everyone, Dankman here. If you're watching this, it should be Monday, May 11. So last week we introduced or reviewed really this concept of multiplying using the distributive property, and we used an area model. So an area model involves looking, for instance, at this rectangle and saying it's got two dimensions, a length and a width. The length is 4 and the width is 5, and so the area of the rectangle is given by multiplying. 4 by 5 is 20. So multiplication represents the area of this rectangle, or a way to find the area of this rectangle. For instance, this area would be 7 by m, or 7m. And we did that in order to talk about the distributive property, like in this case here. We could represent the area of this compound rectangle made of two boxes as a multiplication problem of length, which is 5, times width, which is x plus 7. So that's the area as a product. Or we also could see the two separate little rectangles inside the compound rectangle, and we could see the blue rectangle as being 5 tall and x across, so its area is 5 by x, or 5x. And the green rectangle's 5 tall and 7 across, so its area is 5 times 7 for 35, and adding the blue rectangle's area plus the green rectangle's area gives the area as a sum. Okay? And so the process of writing these products as sums is applying this thing called the distributive property. So you take a product problem, like number 14, 4 times the group x plus 7, and you distribute the 4 times x and times 7 to get 4x plus 28, rewriting the product, the multiplication problem, as a sum and addition problem. Now, I want you to imagine for a moment that we grab this sum, and I were to hand you this sum and say, hey, here's a sum. It's an addition problem. Can you go backwards and figure out the multiplication problem that created it? So again, last week we were looking at a multiplication problem and turning it into an addition problem. We were distributing the 4, multiplying it out, and creating this little addition problem, a sum. This week we're going to look at the reverse process. And that reverse process, that's a thing. That's really a special thing we do in math. Think backwards. Think inversely. And it's a special challenge to go backwards, in much the way that people usually find that division is harder than multiplication. Splitting this sum backwards into its product and recognizing that it's created by doing 4 times the group x plus 7 can be pretty challenging. And we're going to start with an area model again. So here we go. This is going to be page 1 of the handout that you'll be doing today, and I'm going to introduce it. It's called factoring, and I will explain what factoring is in just a moment. It's called factoring a common factor using area. Okay? Fill in the missing information for each. The dimensions, which are length and width, okay, length and width, the area as a product, and the area as a sum. Okay, so let's go ahead and figure out what those instructions mean. Okay, it's important to understand the instructions. So it uses this word factor, and factoring are the following type of idea. Okay, if I take, for instance, the number 22, and I want to ask myself, how can I multiply together to make 22? I can take 22 and turn it into a product, or turn the number 22 into a multiplication problem in my head, because I know that if I wanted to make 22 by multiplication, it would be the number 2 times 11. Okay? And 2 and 11 are factors of 22. Okay? And what's a factor? Factors are pieces of multiplication. They're things that are multiplied together. Okay? So I'm just going to call them pieces for now, because they could be numbers, but they could also be variables or even other things. So pieces that are multiplied, okay, together. And what you're going to do is watch this video and take some notes, and then you're going to look at the handout, page 1 and also page 2, which I will flip to in a moment. In fact, let me pause and show you page 2. So you're going to watch this video, then you're going to look at page 1 and page 2, which are a bunch of practice. And you do not have to print these, because you never have to print anything for distance learning for us. And you can write down all your answers on paper. You don't even have to copy everything down. So I'm going to hop to it. So we're going to factor a common factor with a picture, an area model. Factors are pieces that get multiplied together. Okay, so we're going to take a problem that is an answer, basically, a product, an answer to a multiplication problem, and split it apart into its pieces. Let me explain you. Okay, so example 1 is actually much like what we did originally. We've got a rectangle with 2 as a height here, and x plus 6 as a width. So length and width. So those are the dimensions, 2 by x plus 6. So to find the area of this entire rectangle, we would multiply the length 2 by the width x plus 6. Okay, so this is area as a product, and that's what I put on the top. Okay, however, if we wanted to find the area as a sum, that would mean taking the little pieces inside of it, the blue rectangle on the left and the green rectangle on the right, and finding the blue rectangle's area on its own and the green rectangle's area on its own, and adding those two smaller areas together as a sum. And so you can see the blue rectangle is 2 units tall and x units across, so its area is 2x. And the green rectangle is 2 units tall and 6 units across, so the area is found by multiplication, 2 times 6, which is a total of 12, and adding 2x plus 12 together gives the area as a sum. So we're going to fill in the information that's missing for each rectangle, the dimensions, which are length and width, the area as a product, and the area as a sum. All right? So number 2, you'll notice that the area for the left rectangle is given, the area for the right rectangle is given, the length is given, but no pieces of the width are given. So you're going to have to think backwards a little bit. So let me lead that one as well. I'm going to think backwards. I'm going to say to myself, look, I know that the whole big rectangle has 2 little rectangles in it. It's got the blue rectangle and the green rectangle. The blue rectangle is 5x and the green rectangle is 20 in area. And so I think the total area of the entire bigger compound rectangle could be found as a sum of adding the blue plus the green rectangles together for 5x plus 20. But to find the area as a product, I need to figure out not just the length, which is 5, but the width. So I have to fill in these 2 empty boxes. So the blue one is 5 tall, and to make 5x, it's got to be x across. So I have to ask myself, if the area of the blue rectangle is 5x, and the length is 5, what does 5 have to multiply by across to make an area of 5x? So the number that must go here is x. And similarly for the green rectangle, it's 5 tall, and its area is 20, so 5 times something makes 20. So we know it's 5 tall, and we have to figure out what 5 multiplies by to make 20. And knowing my times tables, I know it's going to be 5 times 4. So I can now see that the entire length across is x plus 4. So the area as product is going to be this dimension, 5, times this whole dimension across, x plus another 4. It's 5 times the group, x plus 4. So on your own, you can go ahead and complete 3 and 4, and I'm actually going to hop down and I'm going to do number 5 and number 11 as examples, and your assignment today is to complete both of these papers, okay? And we'll have slightly more involved practice tomorrow, okay? So we're going to keep intensifying our factoring a little bit each day. All right, so let's look at number 5. It says fill in the missing dimensions from the expression given. So we've got this random looking shapes, but we know what it is. It's a larger rectangle, compound rectangle. It's got two little rectangles inside of it, a left rectangle and a right rectangle that I'll cover with blue and green highlight. Okay, and we can see here up top that we have 5x plus 35. And this expression is the sum expression. So this 5x plus 35 represents the entire compound area. So I'm going to guess that there's a 5x on the left here and a 35 on the right here. Okay? And that's why I have the area as a sum right here, 5x plus 35. Now I've got to think to myself, okay, well, if I want to write the area as a product over here, I have to split 5x plus 35 into two different pieces. And those pieces are going to be 5, and then whatever the other dimension across is. And those two pieces, 5 and the other dimension across, are going to get multiplied together to make the area. So this will be an area as a product. Okay, area as sum, area as product. And so the point here is that we're going to take the area as sum and we're going to turn it into a multiplication problem with two pieces. And these two pieces, the red piece and the yellow piece, are called factors. So this is a process of splitting this 5x plus 35 expression up into two factors. And we call that process factoring. So, since we know one of the product dimensions is 5, one of our factors is 5, I can fill this in, and I just have to think backwards. If this rectangle is 5 units tall, then the blue one is x units across, so this becomes 5 times x to make 5x area. And the green rectangle is 5 units tall, and so we have to think to ourselves, 5 times what gives 35? And it's 7. 7 is the number that multiplies by 5 to make 35. So our dimensions are 5 up and x plus 7 across. So the second factor is x plus 7. So I started with a sum, and I split it into 5, one factor, times x plus 7, another factor. Okay? And that's what you're going to have to do. But they won't always give you one of the factors to start off. So I will go ahead and do number 8 as yet one more example, and then 11. So number 8. Number 8, we've got the area as a sum, 7x plus 21. So I know that one of my smaller rectangles will have an area of 7x, and the other will have an area of negative 21. Okay? And what I'm doing is I'm looking for, okay, going up, I should have the height should be a number that shows up in both boxes. So let's look back at number 5. All right, the number 5 shows up as a factor in 5x, and I also can see 5 hidden in the number 35. So I can see 5 is a factor in 5x and in 35. Here I've got 7x, and I've got the number negative 21. And so what number is a factor in both 7 times x and negative 21? Well, this will be 7 times x, and this could be 7 times negative 3. So I can see the number 7 hidden as a factor in both 7x and negative 21. Since I can see that, I'm going to put 7 as the height of my rectangle, because then I can get 7 times x here, and 7 times negative 3 here, to get 7x and negative 21. And so my two dimensions, when I factor it into two pieces for multiplication, are going to be 7 tall and then x minus 3 across. And that's the game. It's called factoring. One more time. I'll do one more. I have to look at 4x and negative 16, and I have to think, what numbers can I break 4 times x into and negative 16 into, so that I can pull the same factor, the number 4, out of both of them, to create a multiplication problem where the front is 4, and then I've got left over x minus 4. And I've basically undistributed a 4 from 4x minus 16. So one last time here, okay? Before, when we started this whole process, we started with like 3 times x plus 5, and the challenge was to do the distributive property. Multiply 3 by x, multiply 3 by 5, add them together, and get 3x plus 15. Now we're going backwards. We're starting with something like 3x plus 15, and I'm undistributing this 3 from both terms, and then factoring it out from the group. So here I start with 4x minus 16. I notice a 4 factor in both terms. I undistribute that 4 and factor it out of the group. And that is our new challenge. And that's going to take all week just to introduce the topic. Today, the assignment is a set of 2 practice sheets. So get started on that. And tomorrow there's going to be even more practice. So setting aside about 30 minutes to practice factoring each day this week is going to be an excellent choice. Don't forget to sign up for tutorials.